our hypotenuse. Then how we determine opposite and adjacent totally depends on perspective, because opposite means across from and adjacent means next to. If I stand in this corner of the room, that corner is my opposite and these ones are adjacent to me. But if I change my position and I stand in a different corner of the room, that one's now opposite of me and these are adjacent. So you can't automatically label in a triangle opposite or adjacent until you know which angle you're looking from. So in this one, notice they use theta. If you guys, this guy, right? He's theta, he's like a Greek letter, okay? If you took physics, you probably saw it often, holding a spot of an angle. They use it a lot like that. This theta is marked right there in that angle. So all of these ratios are written for that angle specifically, the angle that's the same as angle A. Okay? Now that I know that that's the angle that they're talking about, now I can label which sides are opposite and adjacent. Notice that angle A is made up of the hypotenuse and this side next to it. The opposite side won't touch the angle because it's opposite of that angle in the triangle. So the opposite side here would be lowercase a, and then the adjacent side would be lowercase b. Those would switch if I used a different angle in the triangle instead of that angle to look at. So is everybody okay with setup? We use trig and right triangles. We know what the hypotenuse is. We understand how to label opposite or adjacent depending on which angle we're using. And then we have some way that helps us remember. We either memorized or use SOHCAHTOA or oh heck, another hour of algebra or whatever silly thing we like so that we know how the trig ratios work and are set up. Okay? Is that okay with everybody, the basics? Okay. So then the first thing we're going to do is just practice writing the ratio. Like, can you set up equations? Can you label it correctly and set them up in the right format? And as we go to do this, I want you guys to remember, you don't have to make this note if you don't want to, but if you know you struggle with setting up equations, whether you're using sine, cosine, or tangent, you'll never use them like this. You don't use them all together like this. But I'm just saying, no matter which one you're using, your equation always needs three things from your triangle. You take sine, cosine, or tangent of an angle. So one piece that you're going to need to fill into the equation is an angle from your triangle. And then the other pieces are certain sides. And whether it's the opposite, hypotenuse, or adjacent, that's what you're going to figure out. But the reason I'm pointing this out is because sometimes it helps you guys to realize that every time you're building one of these equations, it's made up of one angle and two sides, meaning every time I build one of these, I want to have three pieces of information I'm looking at from the triangle. One of them's an angle and two of them are sides. And they should have at least two numbers with only one thing missing when I fill in the information so that I'm able to solve it. Is that okay with everybody? Okay. So this equation doesn't ask us to solve for anything. This is just setup. So this is just practicing setup. And it says to set up all three trig functions. Okay. And it already identified the angle as theta. So this is our focus angle here. They told us which one to focus. Sometimes we're going to have to choose that focus angle so we know how to set up the equations. Once we know that that's our angle of focus, we should be able to identify, and there should be a right angle in here, I apologize, the hypotenuse across from the right angle, the opposite across from the angle we're using for our equations, and then the adjacent side of the triangle. Is everybody okay with what we picked out as opposite and adjacent based on the angle that we're using here? Yes, no? Okay. So this angle, the side that doesn't touch it across from it, will always be labeled as your opposite. All right, so it wants us to set up an equation for all three of them. We won't do this all the time when we're solving. This is just practice to make sure we can set up either one of them. Now remember, every equation is built with three pieces of information, an angle and two sides. For all of these, it says to use angle theta. So in all of these, the angle is the piece we don't know, and it's going to just be theta. That's how they have it labeled. And on the other side of the equation, we're going to set up the two sides. And here's where you'd have to have your ratios memorized so you know which two sides to use. So for sine, we want to use opposite over adjacent, which according to our labeling, that's going to be opposite over hypotenuse. So that's going to be 5 over 13. And then for our cosine, we're looking at adjacent over hypotenuse. So that's going to be 12 over 13. And then for our tangent, opposite over adjacent, so 5 over 12. And that's all this is asking for in this one is setup, because I want to work on setup, okay, Can we build a triangle? And then can we use our calculator? Then we can dive in and make sure we have all those skills to just solve stuff. Is everybody okay with setting up these equations once we have the perspective of the triangle? Okay. And so what you're going to be doing in the future is solving for the angle. We'll talk about that in a few minutes. Okay. All right. Example 2 and example 3 are the last things we're going to do before we dive into the final solving of the triangle. Example 2 doesn't ask for all of the trig functions. It only asks for one. It asks you to find tangent A. So literally, I already know that my answer will say tangent A equals, and I'm supposed to write what that's equal to, and I know that it's equal to a fraction where I expect the top number to be from the opposite side of the triangle and the bottom number to be from the adjacent. Is that okay with everybody? I'm just looking at, oh, they're asking me for a tangent. I build that with opposite over adjacent. The problem is, in this one, there is no triangle already built for you. Okay? They did not give you a picture of a triangle. What did they give you? The cosine. Okay? So I'm going to have to use this myself and build a triangle. So the reason this example is here is if they don't put the picture in front of you, can you guys build the picture? Okay? So first of all, we know if we're doing sine, cosine, or tangent, we want a right triangle. So I'm going to just go ahead and give myself a right triangle. Based on what they're asking and what they gave me, that they asked for tangent of A, and they gave me cosine of A, there is an angle in this right triangle that's called A. That's not the right angle because they keep talking about it with the trig functions. Okay? And A is the angle of focus. So this is where I'm focusing. And that means I can label the sides of the triangle, the opposite, the adjacent, the hypotenuse. So is everybody okay with I built a right triangle because they're talking about trig functions. I gave myself an angle A because that's an angle they identified in the question and in the given information. I labeled the sides around that. And now what can I do with this 2 over 3? What can I, that's the only thing they gave me.
You could put the 2 and 3 onto the sides.
Good. Okay.
So 2 would be the adjacent.
Good.
And 3 would be the opposite.
Hypotenuse. Is that okay? So cosine is adjacent over hypotenuse. It's that ratio. So I can plug a 2 in for the adjacent if I use a 3 for the hypotenuse. Now, technically, it might have been like 4 over 6 and reduced to 2 over 3. It doesn't matter. You could use 2 and 3. You could use 4 and 6. It'll all work out okay because we're putting them in fractions, so they'll always reduce back to the same thing. So I have part of my answer for my tangent. I said my tangent's made up of opposite and adjacent. I now know that the adjacent is 2. So I know the tangent ratio is something over 2. Okay? And then I just need the opposite side. They didn't give me the opposite side. How can I find the opposite side in this problem? Okay. Good. Okay, we can use Pythagorean Theorem. So remember, I'm just going to call this little a because it's across from big A. Just make sure you put 3 by itself in the Pythagorean Theorem. The hypotenuse is the side that's by itself in that formula. So we have a squared plus 2 squared equals 3 squared. So that's a squared plus 4 equals 9. So a squared is equal to 5. And then we would want to square root both sides to solve it. Now, I am not writing plus or minus, but I want you guys to understand every time you solve like this equation, if it was just an equation by itself, has 2 answers, plus or minus rad 5. Why am I not including the minus rad 5? Good, because I'm using it in context of a triangle. So I just want you guys to, I think sometimes like we get the wrong impression that like we say there's these math rules and then we're breaking them all the time. We're actually using them all the time, but when we do Pythagorean Theorem, it's always talking about a triangle or a distance. And so we don't use the negative amount because that doesn't make sense with a triangle or a distance. So the algebra would still technically have both, but it wouldn't work for our context. So this is rad 5, and that gives me this ratio. So this is my answer. That's the tangent ratio. The tangent of A is equal to rad 5 over 2. Okay. So the purpose, again, of this example being here was just, oh, don't forget you have the Pythagorean Theorem tool, and are you okay with setting it up when they didn't draw the triangle for you with some given information? Okay. And then the last thing before we solve completely is working correctly with the calculator. So calculator lovers that have been waiting to use your calculator so much, guess what? This unit, tons of calculator work. So there you go. You can enjoy that thoroughly. All right. And so I want to make sure that your calculators are in the right mode and you know how to use them. If you don't have a calculator with you today, you can use your phone. You'll need the scientific version of the calculator on your phone. And then just remember that that works a little differently. I'm totally okay if you're working at home or in class if you use your phone. What it won't work on is like the quizzes and the tests. So try to make sure you have access to at least a scientific calculator. And I kind of want to write it two ways. So these are the same thing, not exactly, the numbers are different, but this says sine of an angle equals this decimal. This says sine of the angle equals this fraction. Obviously, we're going to come across this setup some of the time if we're trying to solve for different pieces of the triangle. And the question becomes, how do you get the angle alone? Okay, how do you get the angle alone when it says sine theta equals 5/13 or sine x equals 0.759? How do I cancel out the sine part or get rid of the sine part and then just have the x or the angle? Does anybody remember? Aubrey? Good, we use the inverse, okay? So if you look at your calculator, right where you see your sine, cosine, tangent buttons, next to that are buttons that look like this. Okay, sine, cosine, tangent, inverse. Those little negative ones mean inverse in this context, okay? So they undo whatever the sine does. So one way that you can think about it, so you guys tend to do well with algebra, is that you're basically taking the inverse sine of both sides of the equation. Like we're pretty comfortable with that, right? That we can do whatever we want to both sides of the equation. We did it with logs and exponential stuff as well. So if I take the inverse sine of this side of the equation and then this side, what I get over here on the left side is an inverse sine and a sine, but those are two things that undo each other. So the sine says, I did something, and then the inverse sine says, yep, and then I undid everything you did. So if you started with x and then you changed it, but I undid every change that you did, you just get back the x. Okay, because this one might change it, but this one literally undoes everything that that one did to x. So we get back just the x. Okay, so x is equal to, how we'd write it without a calculator, in case some of you guys have to take like your math placement tests in college or stuff like that, is that we would just leave it like this. With a calculator, that's what we're going to type in. And I'm going to tell you what the answer is. I want you guys to check on your calculator because it will check the mode of your calculator and make sure that you're in the right mode. If you're getting an answer that's really different than what I get, you're probably in radian mode instead of degrees. We want degrees because we're trying to find angle measures in degrees or use angle measures in degrees. So I'm going to type in inverse sine of that 0.759. So I got 49.376. It says to round to the nearest degree, so we're going to call that 49 degrees. So in this case, x would be 49 degrees. Okay. If you got something like, I'll tell you exactly what you'd got if you were in the wrong mode. Let me see. If you guys got 0.86177, something like that, you're in radian mode and you just need to switch it to degree mode. On a calculator, there's going to be a button for that. On your phone, if you're using your phone and you turn it sideways to get the scientific calculator, usually down in one of the corners, if it says degree on a button, if it says DEG, degree, that means you're not in degree mode, and if you push that button, it will put you into degree mode. So if you got the wrong answer and you see DEG down here on one of the buttons, you need to push that so you get into degree mode. If you're using your phone and you're in the right mode, you probably see an RAD, like rad, on the button, okay? That means you're in degree mode right now. If you push that button, it'll change it to the radians, okay? So just a heads up for that. Is everybody okay with using the calculator for this portion? Yeah, Kristen. I'll come check on it in a second. Is that okay? All right. Do a couple more with us, see if you get the same things, and then I'll check if yours has like a rounding thing set or something like that. All right, so our ultimate goal is to solve triangles, okay? And that's what we're going to do. We're going to solve 2 of these, and then you guys will have some time to start the classwork, or because of the compromise we made, work a little bit on your project. So here's a triangle. Notes on notation. Triangles are generally, or any shape in geometry, if you guys remember, I know it's been a while, They generally label the vertex points with capital letters, like you see here, the A, the B, and the C. So usually the capital letters will represent angles. And then usually what they'll do is they will label the sides across from that with the same lowercase letter as the angle that it's opposite of. So like, for example, 12 would be side A in a lowercase letter, 9 would be side B, 15 would be side C. That tends to be how they label. And to solve a triangle means to find all the missing angles and sides. So we'll know we're done when we have found these 6 pieces of information. And lucky for us, they gave us a bunch of them, right? So like angle-wise, we know angle C is 90 degrees. We don't know any of the other angles. And then side, we actually know all of them. Little a is 12, little b is 9, little c is 15. Is that okay with everyone? Okay, so really the only things we're missing are 2 angles. Okay, what do we know about angles of a triangle?
It adds up to 180.
Good, it adds up to 180. If I had 2 angles, that would totally help me. So sides, if I have 2 of them, I can find the third one using Pythagorean Theorem. Angles, if I have 2 angles, I can just add them up and subtract them from 180 and find the third one. Unfortunately, here we only have 1 angle, and that's why we're kind of stuck. That's when you have to use trig. Okay, so trig was developed specifically for these situations. Like, I don't have enough angle information to just find angles, so I need to use the sides to help me, that kind of idea. When you decide you're going to use trig, okay, the first thing you need to do is you need to start building your equation, but remember your equation requires 3 essential pieces, okay, 2 sides and 1 angle, and that you can't build the equation unless you know which sides you're using, but you don't know which sides you're using until you've developed an angle. So the first thing I would do when I know I have to use trig if I struggle with setup is decide on that focus angle again, okay? So do you guys want to use angle A or angle B as the one that we're kind of like looking at from that perspective? A? Okay, fine. So I'm going to mark it on my paper so I realize that's what I'm using. And that means in my equation that I built, the angle is going to be A, all right? And we don't know A, so that's going to be the missing piece, which means the 2 sides should be numbers that I know, okay? So when I go to build the equation, my angle's A. I already know that. The 2 sides I'm going to use, I don't know yet, but I know I want them both to be numbers or I'm not going to be able to find the angle A. So I want to circle, again, I'm doing this for people who struggle with setup. You know you need 2 sides and you know you need them both to be numbers. Circle 2 sides of the triangles that are numbers. There's not a wrong answer to this, okay? So somebody give me something I should circle. I need a side length that's numbered. So I hear 15 and I also heard 12, okay? That's enough pieces to build an equation, right? An angle, A, that we don't know, and 2 side lengths that we do know, 12 and 15. All right, so now I'm going to put together my equation. If you want to know whether to use sine, cosine, or tangent, you need to know whether you're using opposites or adjacents or hypotenuse. So let's go ahead and label the triangle that way. We know 15 is the hypotenuse because it's across from the 90. Which side is the adjacent?
B.
Good. B, or 9. Is that okay with everybody? Because across from A would be the 12, and that's the opposite. Which means if I'm going to use the A, angle A, 12 and 15, I'm using angle A and I'm using opposite and hypotenuse to put together an equation, which means what kind of equation should I be building? Sine. Sine uses opposite and hypotenuse, okay? So my equation should say sine, and then I put the angle, in this case it was angle A, equals, and then I have to know sine uses opposite over hypotenuse. In this case, that's 12 over 15. Right? And then when you're solving for the angle, this is what we just talked about, needing to use the inverse. So we're going to use the inverse of both sides here to solve this equation. So I'm going to take the inverse of that, the inverse of 12 over 15, so that angle A will equal the inverse sine of 12 over 15. So in your calculator, if you can type things in, you would just type in inverse sine. It usually opens a parentheses, and you would type 12 divided by 15 and close the parentheses. If you're using something like a phone or a calculator that doesn't let you type in, sometimes you have to have the number before you do the inverse sign. Then you would type the 12 over 15 first and figure out that answer, and then hit the inverse sign button, okay? I'm going to tell you what you should get so we can check and make sure that we're all on the same page. So I get 53.13, and this said angles to the nearest degree, so we're going to say 53. So angle A should be 53 degrees. And then how would we go find angle B? Yeah, just add them up and subtract from 180. You can go use sine if you wanted of that angle now and like whatever, I don't know, and use trig or cosine or anything else. But you don't have to, just switch the angle. But we're just going to add them up and subtract from 180. It's a lot easier. You should get 37 degrees, okay? All right, is this okay? And again, I know some of you are like, Ms. Dahl, I don't need to do this whole find the angle, that's fine. I am trying to target people that have struggled in the past with it, right? If you're already on board, you're good. You just need to bring back your solid skills. We're trying to, like, for those of us that don't have that solid skill, what's another way that we could try to set this up and be successful, okay? All right, one more, and that's it, okay? I'm gonna do the same thing I did last time. I'm going to label all 6 parts of the triangle just with their letters. So I have angles x, y, and z. So I'm going to have side lengths little x, little y, little z. And I'm going to know I'm done with this problem when I have found little x, little y, little z, and capital X, capital Y, capital Z. Okay. And again, I'm going to label the things I already know. I know that angle z is 90 degrees and side z is 23. And I know that angle x is 63 degrees. Okay. A little less information than last time, so a little bit of extra work probably for us to do. All right, is there anything we can find without trig first? Y, the side or the angle? The angle, okay? We have 2 angles, so we can just add those up immediately and subtract them from 180, and we get 27 degrees for angle y. Okay. Okay. Now we only have missing side lengths. Can we find them without using trig? No, we don't have enough for the Pythagorean theorem, so we need trig. Okay. So once we decide we're using trig, I'm going to go through that same process again for those of us that struggle a little bit with equation setup. I know I need 1 angle and 2 sides, so I'm going to start by picking an angle so I understand opposites and adjacents and all of those. So what angle would you guys want to use, 63 or 27? 63. Okay, so I'll make this my angle of focus. Okay. So when I write an equation, I'm going to use 63 in the spot for the angle. So it's going to say either sine or cosine or tangent, and then after that's going to come 63. Then I'm going to set that equal to 2 sides on the other side. I already have 1 number, so I need a side that's a number, and then I can find 1 missing side. So basically with the side setup, I need 1 that I know, and then I can use 1 that I don't know. So if I need a side length that I know, what side length does that force me to use here? The 23, right? This guy. And then I need 1 that's unknown. Okay. Let's say I decide to find y. Okay. You could have chosen y or x. I'm choosing y to see a different function than we did last time. Okay. So there's the 3 things that are going to put together in my equation: the 63-degree angle, the 23, and the y. All right. 1 angle and 2 sides. Which 2 sides are these? The 23 is hypotenuse, so I need to use hypotenuse, and the y is adjacent. Which trig function uses hypotenuse and adjacent? Cosine. Okay. So I have cosine, my angle is 63, equals adjacent, which is y, over hypotenuse, which is 23. To solve this equation, you would multiply both sides by 23, because here that would cancel out the 23 and leave y alone. And on the other side, you would be multiplying 23 times the cosine of 63. And again, you can just enter that into the calculator. And that gives you 10.4. This is a side length, and the directions here said nearest tenth for side length, so I'm going to leave it like that. And then we're just left with x. It's the only thing in our list that hasn't been found yet. What are some ways that we could find x? We could use trig again. We could use almost everything the same, except for we would have to use x instead of y, and then which trig function will we be using? Sine, because we'd be using opposite and hypotenuse. What's another option? Pythagorean theorem. Okay, so either way, that would work. If you're using Pythagorean theorem, the 23 would be the part that's alone on one side of the equation. Okay, and so you're going to square 23 and 10.4 and then subtract them. Or you could type that all into the calculator. And you get 420.84. And then we're square rooting that. which gives me x equal to 20.5. A quick check for you guys. This isn't like the end-all be-all of checking. It's not perfect. But in triangles, there's a basic principle that if you make an angle bigger, the side across from it has to get bigger. You make it smaller, the side across from it gets smaller. So at least a quick check to make sure you didn't completely mess something up. You should have smallest angles across from smallest sides and largest angles across from largest sides. So like 90 is our largest angle, is 23 our biggest side. 10.4 and 20.5, yes, okay. 27 is our smallest angle, is 10.4 our smallest side. Yes, so at least it seems like I didn't do something horribly wrong, right? You could go back through your steps, obviously, and check that way too, but at least gives you something to look at. And then I just want to touch on two things. One is vocab, because on Friday, you guys are doing some word problems with these, some application problems, and they use the words angle of elevation and angle of depression. And I just want to make sure that you know what those are. And then I want to point out one thing about the solving for those of you that really struggle with the solving, okay? So I'll turn it back in a little bit, Sebastian.
It's okay.
All right, so for angle of elevation and angle of depression, they use this a lot when they're trying to describe what's happening in a situation. It actually is the most accurate description, but if you're not familiar with the words, to you it doesn't seem very accurate. So here's the thing. They'll identify a subject, maybe a person, maybe an airplane flying in the air, maybe a submarine, a train, I don't know, something, okay? Whatever the subject is, let's say it is Miss Doll. Here I am. I'm really good at drawing, so enjoy thoroughly. Yay, math. Okay, so if this is, okay, my angle of elevation and depression diagram, all right, when they say angle of elevation, elevation means looking upward, depression means looking downward. But you have to understand where they're measuring that from. So it's measured from the basic line of sight. So when they say angle of elevation, they mean if I was looking straight, or if the airplane kept moving on the same horizontal path, okay? Whatever the object is, if it kept going straight instead of going up or going down, that's what you're comparing to. If they say elevation, then they're saying from that straight line, it deviated upward. If they say depression, then they mean from that straight line, it went downward. Like if Miss Doll was like, hey, check out this cool bird in the sky. I'm really not good at drawing pictures, like I said. Or look at this bug crawling on the ground, okay? Those would be the two different things. So this one up here would be the angle of elevation. The angle that you would be measuring would be this right here, between the normal horizontal of whatever the subject is and the upward looking, okay? Then the angle of depression is just the other way. It's still between the horizontal, but it's like you looked downward instead of upward. Okay. Is that okay with everybody? So if those terms are used, you want to draw a horizontal line for the object where it would normally be. And then if they say the angle of elevation between that and this, then you know they're looking upward and you're going to label the angle between their horizontal and the upward look. They say angle of depression between the horizontal and the downward look. Okay.